Hello and welcome. So we're going to be talking about parallel lines and transversals today. So what a parallel line is, it is essentially two lines with the same slope. So these are an example of parallel lines. All right. Now the lines that run through those two parallel lines, this line that's intersecting them right there, that is what we like to call a transversal, right? Now, the one last thing we'll mention, it'll be helpful a little bit, is congruency, which is two objects that are the same shape and size. All right, so let's talk about parallel line angle properties. So first off, we have vertical angles. Vertical angles are a pair of angles opposite of each other. So for example, 2 and 4 are directly opposite of each other. Those are vertical angles, and thus we call them congruent, right? Because they are the same shape and size angle. They're literally the exact same. So if this was 30 degrees, you would be guaranteed that's also 30 degrees. Now, we have angle 3 and angle 1. Those are directly opposite, also considered vertical angles. On the opposite side here, not opposite, but on the other parallel line, you have the same idea. 6 and 8, 5 and 7, those are pairs of vertical as well. Okay, another congruency angle is the corresponding angles. If angles are corresponding, they are congruent. Alas, they are the same. Now, I think of this one as matching corners for my parallel lines and transversal. So, for example, 3 is the top left on the top angles there, and 6 is the top left on the angles at the bottom parallel line. And 3 and 6 are congruent. They're corresponding angles because they're both that top left angle in the group there. So 3 and 6 are corresponding angles. 2 and 5 are corresponding angles. 4 and 7 are corresponding, as well as 1 and 8 are corresponding. Okay. Now the last you have are alternate interior angles and alternate exterior angles. Interior is inside, exterior is outside. Now when we talk inside, outside, we're talking of the parallel lines themselves. So you have two parallel lines. You have the inside of the parallel lines, the stuff in between it, and then you have the stuff outside of those parallel lines. That's what we're referring to with these alternate interior exterior angle theorems. Okay, so for the interior angles, we're looking at the angles 4, 1, 6, and 5, right? But we're talking about those angles on the opposite side of the transversal. So, for example, we're alternating angles 4 and 5, but on opposite sides of the transversal. So an alternate interior angle pair is 4 and 5, 1 and 6. Those are your alternate interior angles. Okay. Now, if we're talking about alternate exterior angles, we're looking at that yellow highlighted section, right? Still on the opposite side, the alternate side of the transversal. So we have 3 and 8 are alternate exterior angles, as well as 7 and 2 are alternate exterior angles. So those are your main 4 congruency theorems when it comes to parallel lines and transversals. Now, we have a few more properties that will be very helpful today. This is going to be your bread and butter, is going to be your supplementary angles. And that essentially means that on any straight line, all angles on one side of that straight line are going to add up to 180 guaranteed. So for example, A and B here add up to 180. If it's split into more angles, as long as they're all on the same side, A, B, and C, they add up to 180. Okay? And just notation, if you see a little box, that's always going to mean a right angle. Okay? And then the last but not least is your interior triangle sum angle theorem. A bit of a mouthful there. And that essentially says that all 3 angles in any triangle, regardless of its shape, will add up to 180 degrees. Okay, so that's all the vocab. All the vocab we're going to need for this, so let's actually get these in. So example 1, it says, given 2 parallel lines, find the measures of all of the angles given that our first angle is 95 degrees. There's a lot of different ways we can do this. All right, so for example, 1 and 3 are vertical angles, so that guarantees 3 is also 95 degrees. You could say, oh, corresponding 3 and 6 are corresponding angles. That would put 95 degrees in this corner. Or you could have also said that 1 and 6 are alternate interior angles and thus congruent as well. Okay. By the same idea, you have alternate exterior angles with angles 3 and 8. So that means that this is also 95 degrees here, which you could have found by a vertical angle pair as well. Right? These theorems all work together. You can get all of those angles. Now, you may be wondering, how do we get 2, 4, 5, and 7? Well, what we're going to use is your bread and butter supplementary angles. Because we have a lot of lines here, and I know that as long as you're on two sides of the same line, that must add up to 180 degrees. So if I know 95 is angle 3, that means 180 minus 95 should be your angle 4, which gives us 85 degrees as the remaining angle. So let me kind of put that out a little bit. So we have 85 degrees. And then we can use those exact same angle theorems, vertical angle, 4 and 2. So 85 degrees is there. You can say an alternate interior angle with 4 and 5. So this is also 85 degrees. A vertical angle pair tells us 85 degrees here. We also could have said a corresponding angle with 4 and 7. A lot of different ways we could have done that. But now we know angles 1 through 8. We answer the problem. Okay. Now, what you're going to see is those are really easy ones with example 1. Example 2 is when we start getting a lot more creative with our angles, right? So let's kind of just start on the outsides and work our way in. So vertical angle pair tells me angle P here is 115 degrees. I can say because it's on the same side of a line, that must add up to 180. So that means that 180 minus 115 is going to be angle Q, which would tell us 65 degrees, I believe. Okay, so 65 degrees for angle Q. And then vertical angle pair, 65 degrees for angle O. Now, we'll notice that because you have parallel lines with the same transversal, you can also use any of your angle theorems to find L, K, M, and N. So it's all right. Well, let's see here. We have a corresponding angle, 65 with M, a vertical angle with L, so that's also 65. All right, and we can do the same thing, a corresponding angle with K equals 115, and then a vertical angle to get us N is also 115. Okay, now as we hit this third one, you'll notice that here's your parallel line, but either of these lines, those are not parallel with our, let's see, what line is this? We don't have it labeled, darn, right? With our green highlighted parallel line, the other two lines aren't parallel with it, so we can't use any angle theorem, any of those four, for H, I, or J. Darn it. But that's actually okay, because we know one of the angles up there, and that is 80, which means this is also guaranteed to be 80. And supplementary angle, you know that has to add up to 180, which means that your angle right here must be 100 degrees, because 100 plus 80 is 180, same side of a line, 180. There you go. And then vertical angle pair, you also magically now know H. All right, so then the question is, how do I find these? There's a couple ways we can do it. In my opinion, what's going to be the easiest is an interior triangle sum. Because you notice we have a couple of triangles. We have an overall triangle right here. We know that all interior angles add up to 180 degrees. Or you can go even bigger and you can say this whole triangle should also add up to 180, 65, 80, and angle R. Whichever triangle you want to use, it's going to work. I'm just going to use the smaller triangle here, so I know that this triangle is going to be 180 equals our 80 plus 65 plus G. All right, so that means that when I actually solve back through this, we're essentially going to get 180 minus 80, 100 minus 65, and we get G is 35 degrees. Okay, vertical angle, 35. You could say supplementary, you can find that right there. 180 minus 35 gives us 145 degrees, because we know that anything on the same side of a line adds up to 180. Vertical angle pair, we know that's also now 145. And because we're looking at this, two parallel lines with the same transversal, that means your angle theorems will totally work to bring you to those four angles down there. You could say, all right, you could use corresponding angles, E and B, 145 degrees. You could also use an alternate interior angle with C to give you 145. We could also say alternate interior for 35 degrees there, or alternate exterior with G and A will give you 35 degrees. Right? There's a lot of different angle theorems that you could use. There you go. We found all of the angles. You're good to go. So take your time with these. Keep in mind that they have to be parallel lines with the same transversal to use your theorems. But also remember you have things like supplementary angles in the interior triangle, so I'm going to help you. All right. Now on these ones, we're just going to kind of briefly solve the bare minimum of what we need, and then I'll kind of leave the solving a little bit more up to you. But on these ones, we have given lines N and M are parallel. We're given also angles 2 and 3, and it says find the measure. So that means we not only need to find out what the x is, what value x is, but we also need to plug it back in and figure out what the angle itself is. All right, so we know angle 2. We know angle 3. So we know angle 2, we know angle 3. And we also know that 90-degree angle there. It's not denoted as a box, but it is told to be 90, so we could put a box if we wanted. And I look at that and I'd say, okay, well, if we know angle 2, angle 3, how do angle 2, angle 3, and our 90 degrees relate? Easiest way? Supplementary angle. They're all on the same side of a line, which means they must add up to 180 degrees. So then from there, we know that 180 equals angle 2, which is 6x plus 9, plus angle 3, 3x plus 9, plus our 90 degrees equals 180. And from there, you can literally just solve for x. Combine like terms. 3x and 6x gives us 9x. 9 plus 9 plus 90 gives us 108. All right, subtract the 108 and divide by 9. 9x equals 72. Divide 9x equals 8. So if we plug that back in, now we know that x equals 8. Plug it back into our original expressions, and we get angle 2 is 57 degrees. We get angle 3 is 33 degrees. Okay, and once we do, now we know the actual numeric measures of these angles, and you can start solving the rest of these. I'm going to go by these a little bit quickly. So angle 3 we now know is 33 degrees and 57 degrees for angle 2. You can use supplementary to go back here. You'll find out it's 90 degrees because that's also a vertical angle. All right, so then from there, because you have a couple of ways to do this, we have two parallel lines, same transversal. You have to be careful because of the double transversal right here. So that means angle 1 is not the same as 4, right? But you'll notice that angle 3 and 5 are corresponding angles. They're formed from the same transversal. Your second transversal won't affect it or doesn't affect it. So that means this is also 33 degrees. Supplementary angle 180 minus 33 gives us 147 degrees. All right. Now, to solve our last little section, 6 and 7 down there, I'm going to use an interior triangle angle sum. So I know this is 33 degrees right here because vertical angle. I know that's 90 and 33, which means this should be 180 minus 90 minus 33. Oops. In other words, 57. And we also could have found that right there from a corresponding angle. All right, and then supplementary angle 57 minus 180, and we get 123. So now we know all angle measures as well as our value of x. Okay, as crazy as it gets, there you go. Now, these next ones, we'll go by really quickly on these. Example 4, solve for x and y. So when we're looking at this, we have x, we have y, you have two variables. All right, what I would recommend is because you have two y's, I would solve for the y's first. I would figure out how does the stuff relate and use that to form an equation. So let's look at our angles. I know that this angle right here is congruent by vertical angles to that one. which means corresponding, it's going to be congruent to this angle here, which isn't the same as 3y, right? This angle is not the same as that angle right there, but they do relate. They're supplementary, meaning that the angle we want, right, our 6y minus 9, and our 3y, when you add them together, they equal 180 degrees. And this is going to be key for everything geometry. Figure out how it relates geometrically to create an equation to solve with. And then you literally combine the y's, right? 9y minus 9 equals 180. Add the 9, so 189. And then divide by 9, and you get y equals 21. All right, and then you can literally just plug that in. What's 3 times 21? Well, that's 63. And now you know the angle measure. Okay, so from there, we still need to solve for x. We now know what y is. So now let's find x. So I'd say, all right, so we know that this angle right here, 3y, or 63 degrees, is corresponding with 2x plus 13. Remember, corresponding means they're congruent. They're the same. And you denote things that are the same in mathematics with an equal sign. So that means that 63 equals 2x plus 13. Solve for x. Minus 13, we get 50, and half of 50 is 25. You've now solved for x. Right? It just says solve for what? X and y, and it wants the measure of the 3 angles. Well, that's pretty easy to do. So I know x is 25. So if we plug that in, you should get 63 back. That's how you know those angles are congruent. Okay, and then to find the measure of our angle for our 6y minus 9, you know what y is? Plug it in. We get the number of, looks like it's going to be, it's 180, what is that, 117, I believe? So 180 minus 63, I'll double check that. Yes, 117 degrees. So there you are. There's the measure of the 3 angles as well as the solutions for x and y. And even if you have a quadratic like here, it's still going to be the same process, right? If you know angle 6 and you know angle 1, how do angle 6 and 1 relate? And it's either they equal each other or they add up to 180. You'll notice that here is an alternate interior angles, right? 6 and 1 are alternate interior angles, meaning that angle 6 equals angle 1. They are congruent. Well, you just happen to know what angle 6 is. That's x squared plus 12x. You just happen to know what angle 1 is. That's 15x plus 40, right? Now you have an equation. Now keep in mind, bells should be ringing. Anything x squared tells you quadratic, right? That tells you that you should probably get everything onto the same side. And then factor or solve by the quadratic formula. Or complete the square if you want to. I'm going to just factor for this one, all right? There's no GCF, so we go on. So what adds to negative 3 but multiplies to negative 40? That's negative 8 and positive 5. You have a leading coefficient of 1, which tells you can go straight to your parentheses. All right, set those mini equations to 0. And x equals 8, and x equals negative 5 when you add 8 and minus 5. So with those two solutions, the only thing you need to double check is to make sure these answers work. Because yes, you solved for x, but x was in relation to a geometric diagram. Keep in mind that we have restrictions with angles. With geometric diagrams, angles must be positive. You can't have negative angles in a picture, right? Negative angles are a thing, but not in geometry like geometric diagrams. So keep that in mind, no negative angles. We also have to keep in mind that we can't have angles of 0. That wouldn't quite make sense. So all we're going to do is we're going to go back to our original angles. We have the answers of 8 and negative 5, and you just plug them in to make sure they work, right? So let's check 8. If I plug 8 in, we get 64 plus 12 times 8, which is 96, which gives us 160. Is that a positive number? Yes. That's not an issue. Plug it into the other one, 15 times 8 plus 40. So that should give us let's see, 120 plus 40, which is 160, right? And you also know that it works because we said our angles were congruent. We got 160 both ways. So 8, valid solution. Double check it with -5, -5, parentheses, if you plug that in, squared, plus 12 times -5. So we have 25 minus 60. That's -35. Now, that's immediately a problem. I don't even need to bother checking angle 1 because angle 6 just kicked the bucket, right? No negative angles in geometric diagrams, which means -5 does not work, and you only have one solution of 8. Okay, now technically we should have been checking this all the way. We have been, right? Positive angle, not 0, positive angle, not 0. When we plug these in, positive angle, not 0, positive angle, not 0, right? We've technically been checking that all the time, but you're going to see angles fail it's more likely to fail or more common when you have double solutions. Okay, and that's literally everything you could possibly see with parallel lines and transversals. Thanks for watching.